Let's just talk about electrical circuits. So say you have some device that adds a potential difference to your circuit, to a system. So let's put a battery. We've got a positive plate. Remember, we say we've got a positive plate, we've got a negative plate. And say we run a wire from that end to that end, and let's stick it through, let's stick it through a light bulb. Now it's back up here. We will actually have a potential difference, a voltage, a potential difference between these two plates, and this will cause a current to flow. Now, we always say, the current flows from positive to negative, which is quite interesting because in reality the electrons actually, this is a big one, flow negative to positive. So even though we know the electrons, we know that the little electrons go that way, we say that the current, and the symbol for current is I, we say that the current goes that way. So why would we say that? Why would we say the current goes this way when we know in reality current is a flow of electrons? Current is the flow of electrons of charge, and usually that charge is going to be electrons because they're small and easy to move. And the answer is very simple. Back in the day, like 1700s, they were sticking, as I said before, copper and iron into a potato or into a lemon, and then they were getting a voltage across them. V is the symbol for voltmeter when drawn in a circle like this. And they measured that there was a voltage. And they said the current has to go from one direction to the other direction. So they said it goes from plus to minus. This is before they did. And then it was only like 100 years, 50 years, 100 years later that they discovered the electron and realised actually the current when the rod was going that way. And by then it was just too late to change. All the textbooks said it went that way. So ever since then we've said it goes that way. So we call this conventional current. And conventional just means, convention is an agreement, so conventional current is positive to negative. And as long as you're consistent, with the maths, it'll all work out right in the end. Occasionally we have to know which way the electrons are going. Okay, so let's actually get back to, we were talking about current. What is current? What is electrical current? So basically electrical current is the flow of charge. And so current has the symbol of I, that's the symbol. And I, current, is equal to the amount of charge, it's equal to Q, the charge, over the time. So basically how much charge goes past the point. Usually the charge is going to be measured in coulombs. Remember, 1 coulomb is what, 6.024 times 10 to the 19 electrons? Well, something like that. 6.24, yep. 6.24, yep. So time is measured in seconds. So current is coulombs per second. And we have a special name for that. We call that the amp or the ampere. So remember, 1 ampere is equal to 1 coulomb per second. So 1 ampere equals 1 coulomb per second. Okay, so this only works if there's a wire or a conductor that goes all the way around and goes up there. If we put a break in there, like a switch for example, then current can't flow. There must be a conductor that goes from the positive plate to the negative plate, or actually relative negative plate to the positive plate. Okay, so let's try example 4.8, which is example 4.8, which is a circuit has 5 coulombs of charge passing every second. What is the current? I'll pause now if you like playing that game. Work it out. So I is equal to the charge over time. We know, so we have our battery. We'll measure it. It goes around, comes up here. What do we know? Charge. Current. Charge equals 5 coulombs. Time equals 1 second. So the current's going to equal 5 coulombs over 1 second equals 5 amps. And the next question, what is the number of electrons that are passing through that point? So remember, that's 1 coulomb equals 6.02 times 10 to the 18 electrons. So therefore 5 coulombs equals 5 times 6.02 times 10 to the 18 electrons, which is equal to, what's that, lots, 30.1 times 10 to the 18 electrons per second. Let's just check. 3.1 times 10 to the 19, yeah, okay.